today you are welcome to today's class. We will be looking at Bernoulli equation, Riccati equation, and Clarence equation. So all these equations are very important to us. I'll show us the proof, and I'll give us the one or two examples. Once you know the method of solving it, then I believe the rest is simple. Priye, is it your first time in this class?
Yes, sir.
You said?
Yes, sir.
Wow. After 8 weeks, you are welcome.
I just got the email of recent.
You just got the email. You didn't check your email. It's not you just got it. If you've been checking your email, you will see a lot. I've been sending mail partially every week, but unfortunately, those emails probably they are not delivered on time for you guys to see, or because of the system we are running, maybe it might be causing a lot of difficulties for some of us. So let's proceed. Can you see my screen now?
Yes, sir.
Can you see my screen?
Yes, sir. Yes, sir.
Yes, sir.
For those of you that are on your video, you can off it if you know the bandwidth will be disturbing you. Otherwise, you can on it. I don't have problem with that. I'm just saying it because of others too. So today we'll be looking at Bernoulli and the three mathematicians that I mentioned. We'll be looking at them, their works. How do we identify the question? Because that is the major thing. So we discussed about Isaac Newton before, and there's another French mathematician called Clairaut. Alex Clairaut, 1713 to 1765, introduced the idea of differentiating the given differential equation in order to solve them. He applied it to the equation that now bear his name and published the method in 1734.
Yes, sir. Decrease not showing, sir.
In 1934 is 1734. So today we will be talking about it, and we will also look at their work, the way they solve it, what are the solutions, and they have. Is this method applicable to our day-to-day? Yes. So, example, let's look at it. I think I'll start with the Bernoulli. Give us the proof of the Bernoulli, then we'll now solve it. Please, once you make noise in my class, I'll put you in waiting room. You make noise, I put you in waiting room. So, except if I ask you to talk. If I ask for a question, then you can talk. Not because of me, but because of others. Bernoulli, Riccati, and Claros. So let's look at the Bernoulli equation. Bernoulli differential equation. Bernoulli differential equation. Now we have the y, the x, plus p of yx, y, equals to f of x, y raised to power n. Where your y raised to power n is what we call an extra factor. Let's call this one equation 1. If I have it to be equation 1, but let me solve this one by saying we want to use substitution method now. Let W equals to y1 minus n. So remember we have y raised to power n. So we now say let W equals to y1 minus n. So if you now set the W, the x, what will happen in this case? Always remember that the W, the x, there are certain things it will not be able to solve. Some guys are disturbing, which we need to. So the W, the x, now who can tell us if you are given this type of equation and they ask you to differentiate with the W, the x? Remember what it means? Using implicity function. So it's going to be equals to 1 minus n y minus n dy dx. In implicit function, when you differentiate y with respect to x, you need to add dy dx to it. If you still remember, if not, you can check your calculus book, you will see this there. Dy dx will now be equals to 1 minus n raised to power minus 1, y raised to power n dw dx. What I did here, who is not clear to? I made the y dx subject of formula. When I made the y dx subject of formula, what happened automatically? Automatically, the y dx, who can tell us what happened? Do you agree with the response?
Yes, sir.
Okay,
Yes, sir.
I get minus 1, sir.
Okay. So let's continue. Now, if I have this. Then my equation 1 becomes,
Hello, sir.
yes,
Sir, please, how do you get the power of n minus 1?
remember it's going to be 1 all over 1 minus n, which is the same thing as 1 minus n raised to power minus 1. Do you agree?
Okay, yes, sir.
Yes, sir.
So it's going to be equation 1. Remember your equation 1. Equation 1 becomes dw, our dy now we substitute. We substitute our dy. It will be dw dx in bracket 1 minus n minus 1 y raised to power n plus p of x y equals to f of x y raised to power n. The only difference is we just substitute the y dx. So we proceed from there by saying that after we've done this, we divide through. Let's divide through because we have y over n in both sides. Divide through by y raised to power n. If I divide both sides by y raised to power n, I'll left with the w, the s into 1 minus y raised to power n over y raised to power n plus p of x, y over y raised to power n equals to f of x, y over n over y raised to power n. Because we already told us that we are going to divide through by y raised to power n. This one goes with this. This is go with this. So at the end of the day, I have this left. So what is remaining there is what? The w, the x into 1 minus n is to power plus p of x y raised to power 1 minus n is equals to f of x. Any question? No question. You recall that this is the same thing as w. Do you agree with me? If you go to our w up here, we said let w equals to 1 y raised to power 1 minus n. So it simply implies that the w, the x, into 1 minus n raised to power minus 1 so if I want to, okay, let me just write it. P of x, P of x, w equals to f of x. Now let's multiply through by 1 minus n. So we're going to have the w, the x, this we cancel, plus p of x, w, 1 minus n, or you can put it this way, the other way around, by saying 1 minus n P of X, W, equals to 1 minus N P F of X. So then our linear in W now, we can now begin to substitute. We can solve for W to substitute our answer at the end of the day. So that is one of the things this can give us. But let's look at the answer. Let's look at the example of this problem. How do we solve it? So, example. Example 1. So in this case now, all you need to do is solve for W, then substitute.
Hello, sir.
Right.
So, sir, what we got now is it a formula or an equation?
That's the method of solving it. We are solving the example now, so you will see the way we solve it. The way we derive it, that's what I just quickly show you. But now let's look at the example. So example 1 says the y, the x minus y equals to exponential x, y 2. So the question is, how do I know what to do when I'm given this type of question? I just show you some part of it the other time. If you look at this, I think I saw something of that nature in one of the questions. I'm not too sure whether it's this one or the other one. So when you look at the past question, you can also lay your hands on some of them. Okay, let's look at it. Solution now. For us to solve this problem, remember that the other time we have y raised to power n. And when we have y raised to power n, let me just digress a bit so that you have idea of what to do when you have this. You have y raised to power n the other time. So y raised to power n the other time. Then we now lead this to, we said let w equals to y raised to power 1 minus n. Now we have y raised to power 2. What is the w will be?
Excuse me, sir, we cannot see the screen.
You can't see the screen?
No, we can see it. We can see it. We can see it.
Who cannot see the screen, please?
We can see it, sir.
It's me, sir. I can't see the screen. Okay.
You can't see, probably your network. Try and move to where you can get a good network.
All right.
If you are using video, you can off the video so that it will increase your bandwidth. Can you see it now?
Okay. Yes, I can see it now, sir.
Okay, good. So The question is, when we are proving the method of solving it, we have y. Okay, let me go back a bit so that you will understand where I'm coming from. So when we are solving this, you can see what we have. We have here y raised to power n. But in our question says y raised to power x, y raised to power 2. What is f of x? What represents f of x in our own case is exponential x. So you can take note of what we are. You will see they are in form of the same thing. So the equation we have is in form of this, the y, the x. Let me just write the form of the equation so that you have idea. Plus p of x, y, equals to f of x, y raised to power n. That is the nature of the equation we have. What represents dy dx is dy dx. What represents p of x is -1 of y. What represents f of x is exponential x. What represents y squared is y raised to power n. So in this case now, we now have y raised to power 2. So what will be our w? I'm listening.
So our W will be having a 1 minus n squared.
1 minus n squared.
Yes, sir. If W is there, 1 minus n, that will be 1 minus n squared.
Yes. Then what is w? Anyway, don't let me waste that. You said what?
Our W is going to be 2 minus 1. 1 minus 2. Sorry.
1 minus 2. Thank you. 1 minus 2. So you have -1. So we said, I'm going back to the question now, solving the problem. W equals to y raised to power -1. Please. Now we cannot differentiate. Look at what happened the other time. We differentiated this, differentiate the y, the x, the w, the x rather. When you differentiate it, you have negative y raised to power -2, the y, the x, because we are differentiating implicitly, implicit function. So we are looking at implicit function now of this. So it's going to be what? Now that we've done the differentiation, we have the w, the x equals to -y -2, the y, the x. So what is the y, the x? How do we make the y, the x subject of formula in this case? Who can tell us? How do we make it? Make the y, the x subject of formula. Anybody? What do you have? Nobody? Going? Make the y, the x subject of formula. That is, divide both sides.
Yes, sir. Divide both sides
by what?
Divide the s.
No. You don't need to take the y, the x again. You divide both sides by negative
y.
You need to see when you have
Divide x.
Divide both sides by what?
Minus negative.
Divide both sides by minus y squared. Do you agree with me? So if you divide both sides, no, multiply, sorry. I need to say multiplication. Multiplication, you have to multiply both sides by, because when you multiply, that's where it will cancel this.
Yes.
Do you agree with me? Okay. Nasiru, that's your last time. I put you on waiting room because your background is making noise and you refuse to mute yourself. Okay, so you multiply both sides by negative y, multiply negative y, negative y2, the w, the x, equals to minus negative this, multiply by minus y raised to the power minus 2, the y, the x. So if I want to write this one on the number, it's going to be minus y2, the w, the x equals to minus y squared. Bring one down, minus times minus plus. This one will cancel this, making plus. So I have y over 2, and there is another 1 over y over 2, the y, the x. So this will go with this. So at the end of the day, our dy, the x, will be equals to minus y squared TW dx. Any question? Any question? No question. Silence means no question. Okay, the next thing is, remember, we have original equation, which is equation 1. So let's call this one equation 1. So your equation 1 becomes what? What happened to the equation 1, please? We said equation 1 becomes, we substitute our dy dx into the equation 1 now. Equation 1 becomes, your dy dx will be negative y squared the w dx minus y equals to exponential x y squared. So what do we need to do? We divide both sides by negative y squared. Divide both sides by negative y squared. When I divide both sides by negative y squared, I will have negative y squared dw dx over negative y squared So what do we have again? When we divide both sides, minus y over y negative y squared equal negative exponential s y squared over y squared. If I divide both sides, what do I have? This go with this. This go with this, and negative cross out. So I'm left with this. So what do we have? Anybody? So we are left with the W, the X, minus times minus plus, plus, here goes year 1, y raised to power minus 1 equals to minus exponential x. Remember, you must get that W back. We can substitute the W there by saying equation 2 becomes
Excuse me, sir.
what?
Please, yes, exponential x. How did it become negative?
Remember, we divide both sides by negative y over 2. Negative.
Yeah, negative power of y.
Yes, yes.
Have you seen it now?
Yes, sir.
Okay. So automatically it will affect it.
Yes.
So now you agree with me that we have the W, the X, plus W equals to minus exponential X. That is what we have now. How do we solve situation like this? This is a linear equation. And I've taught us how to do it using integrating factor. You have a lot of questions on integrating factors. We have the formula for integrating factor is what? Based on our knowledge,
1 over
integrating
1 plus
factor is equals to rho because exponential integral of the x equals to exponential x. Now, but in this case, how do we solve it? Anybody with idea? Who can tell us? Yes, I'm waiting.
So we can integrate the right hand side.
We can do what?
We can integrate the right hand side.
Okay. It's not the issue of right hand side. It's the issue of just picking your P of x and substitute it. How do we do that? Anybody? Any question? Who want to help us out? Just think as a mathematician, think like a mathematician. Yes. Should I be calling name? Nobody. Okay. At this point, we use integrating factor. So what will now be the way out for the integrating factor? Who can tell us? Okay, if answer say no, then I can go ahead by solving it by saying, if I bring this one in, what do I have? If you do the integrating factor very well, you will have exponential s omega prime equals to minus exponential 2x. Remember that when you are solving the problem with the negative, with the quadratic, with the exponential rather, what will happen? Based on the points that I gave you last week, what do you have? In the upper week rather, when we are solving the integrating factor. Anybody want to chip in? Check your notes. If you don't have the notes, please avail yourself to my videos on your platform or on the YouTube and make sure you have idea of what it simply means. When you have exponential, what do you have? How do you solve it?
So the answer will be minus 2s exponential 2s.
Minus 2s exponential 2s. Where do you see minus 2s exponential 2s?
But when we're multiplying the exponential, that is the power, by the minus. So it will give us.
You have multiplied exponential by 2, right?
Yes, sir.
Okay. Can you explain it for us?
You know, sir, if you differentiate exponential, we still give you exponential. But
Yes.
because the 2 is there, so that will be coming down. So it will become minus.
If that will happen, if 2 is coming, that's going to be 1 over 2. Am I right? So the prime means what? The prime means differentiation, right?
Okay.
So by the time you integrate this side, what do you have here? The prime will cancel dw, the x will cancel, we have it to be exponential of w equals to that. Integrate this one, you have negative 1 all over 2 exponential 2x plus c. Then don't forget that you have w to be your y raised to power minus 1. Substitute your w back, you have exponential s y raised to power minus 1 equals to negative 1 all over 2 exponential 2x plus c. Any question? If I make y prime subject of formula, what will happen? Y prime subject of formula is going to be, that means I will divide both sides with exponential x. You know, you have exponential x, you have by exponential s here, minus 1 over 2 exponential 2x divided by exponential x plus c over exponential x. Remember, this will go with this. After that, you have y raised to power minus 1 equals to, remember that this is the same thing as minus 1 over 2 exponential 2x dot exponential minus s. You agree with me? Plus c exponential minus s. Any question with that? Constant multiplied by anything is still constant. So we can resolve this one by this to be minus 1 over 2 exponential 2s minus s plus c exponential minus s. So at the end of the day, when you solve this one clearly, what do you get here? You have y raised to power minus 1 equals to minus 1 over 2 exponential x plus c, because constant multiplied by anything is still constant. But in this case, I have y over 1 over y equals to minus 1 over 2 exponential s plus c. Now the question is, we need y. How do you get the y? That means it is a reciprocal of what we are dealing with. Our y will be 1 all over y will be y equals to negative 1 all over 2 exponential x. So it's going to be, for me to get the y now, it's going to be 1 all over everything minus 1 all over 2 exponential x plus c exponential minus s. So that is going to be your solution. Any question?
But how do you manipulate that one to become 1 over?
You don't need, it's just a simple arithmetic now. Make y subject of formula here. I don't manipulate anything. This is elementary mathematics. Right?
Yes, sir, but the one is just surprising how you get that
Go
1
and
over.
do it now. That's why you are in the class. Bro, you are in part 2 or part 3. What level are you?
Part 2, sir.
Part 2 of mathematics, or what department?
Yes, my department.
Mathematics. And you are asking me this question. I'm sorry. That's why I'm trying to take my time to explain it in detail so that some of us can also learn 1 or 2 things. So that does not allow you to take it for granted. For me to be doing 1 plus 1 for you, I know you got to do it by yourself, bruh. Okay, let's look at when you are given Bernoulli. How do I know my Bernoulli must be in form of this equation? My Bernoulli must be in form of this equation. I must be able to read all these equations in my Bernoulli. The y dx plus p of x, p of sy equals to f of x y raised to power n. Please take note of that. So let's look at the Riccati equation. And how do we solve the Riccati equation? I will also explain the formula again, the method of solving it. Then we can now solve it. Riccati equation. The first order, the ordinary differential equation. So Riccati equation is in form of the y, the x equal to a of x, y squared, plus b of y, b of x, y, plus c of x. Riccati equation is quadratic independent variable, whereby you have v equals to v of x and y1 equals to y particular. The v is also a variable of x. So now let's look at this. Let y equals to y1 plus 1 all over v. y1 plus 1 all over v. I want to put through the way of solving it, where v is equals to v of x, then y1 is equals to particular solution. D is a variable of x. D is a variable of x. So now we can proceed. Let's differentiate y. We are talking about this equation now. Equation star. From equation star, the y, the x is equals to the y1 over the x minus 1 all over v square dv dx. Remember, please always remember that in this case now, so many things are involved. So many things are involved. I'm using implicit function to differentiate that v with respect to x. Like I told you, v is a variable of x, v of x. So take note of that. Then we now have a of x, y squared, plus b of x, y, plus c of x, plus c of x, which is equals to a of x, y squared 1, plus b of x, y1, plus c of x, and minus one all over v squared dv dx. How do I come up with this? Remember, we said our y is equals to y1 plus 1 over v. So we already have the pre-notion of what is y is to look like. Then I know my dy dx is here. Let's go up. Look at it. Your dy dx is here. So in this case, if my dy dx is there, I will substitute my dy dx here to be in this shape. And I will now put, since I know dy dx is there, I will now differentiate. This is y, the y1 over the x. So the y1 over the x, we just change. Everywhere I see y in my equation, I'll just put 1, 1, and remain the same. So don't forget, this aspect is also part of it. That is what I joined to this one. Any question? You need to get this basic correct before we go into detail. So now that I believe that we all know, we can now begin to substitute. Let's take it one after the other. Let's go to A. A, in this case, we have y squared. What is y? Our y is being...
Our y is y1 plus 1 over v.
Thank you. Y1 plus 1 over v, all squared. Plus b of y. Y1 plus 1 over v. Plus c equals to...
But sir, what happened to the s, sir?
What happened to?
To the s, you know the s, you know we have...
No, we
S,
know they are variable of x. Just know that
okay.
they are variable of x.
Okay.
Are you getting it?
Yes, sir.
Is that you are saying what happened to the v of x? Is still the v.
Okay, sir.
So in this case now, we now equate it. You know, everything is in y1 now. We now put it a y squared 1 plus b y1. Are you following now?
Yes, sir.
Plus c minus 1 all over v squared dv dx. Good. So we now need to open the brackets one after the other. We need to eliminate v squared. Remember, you have v squared here when you open the bracket here. When you open this bracket, you have v squared somewhere. So you don't need to open it. All we need to do is that multiply through by v squared. Multiply through by v squared. Sorry. Are we there now? Can you still see my board?
Yes, sir, we are seeing paper
Yes,
solution.
sir, we can say it.
Okay. Multiply through by v squared. If I multiply through by v squared, all that remains there is I will have here a y2 1 plus. Okay, probably I should ask us to open this bracket first so that you understand what I'm doing. Let's open this bracket first.
Okay, sir.
If you open this bracket, y1 plus 1 over v, multiply by y1 plus 1 all over v. Y1 multiplied by y1, y1
Y1
plus 1 y1 over v plus y1 over v, then plus 1 v squared. Do we all agree with this?
Yes, sir.
So this particular things, what do you call it? You have y2 1 plus what?
Okay, I also will be, I guess the first will be having 2y1 over v plus 1 over v squared.
Do you agree?
Yes, sir.
Yes, sir, I agree.
So I'll take this one back to this equation because I will clean the board. So let me just clean all this one first. So by the time we have a in brackets y squared 1 plus 2 y1v plus 1 all over v squared plus b into y1 plus 1 all over v plus c everything equals to everything now equals to a y21 plus b y1 plus c minus 1 over v squared dv dx. So, which implies a which implies what? A y squared 1 plus 2a y1 over v plus a v squared plus b y1 plus b over v plus c. Now, everything now equals to a y21 plus b y1 plus c minus 1 all over v squared dv dx. I'm supposed to write everything on a single line, but because of explanation that I'm trying to do, I may not be able to do that. So you agree with me that this cancel this? Do you agree? Hello?
Sir.
Do you agree this cancel this?
Yes, sir, I agree. I agree, sir.
Okay.
Yes,
Then
sir.
this go with this. Do we agree?
Yes.
C go with C. Because if the other C move to the other side, it returns to negative. That's why it's cancelled.
Yes,
Yes,
sir.
sir.
Yes, sir.
So anyone that I say it's cancel, it's because when they move to the other side, they will turns to negative, and positive and negative will cancel each other. So that's just the reason. Then, after I have shown us this, I can now say, let's see what remains. I have 2a y1v plus av squared plus bv. This is not bv anymore. It's just b over v equals to minus 1 over v squared dv dx. Now, we need to be strategic. Multiply both sides by v squared. Multiply both sides by v squared. If you have to multiply both sides by v squared, what happened?
We have 2 AV,
You have 2a
Y1.
y1 v squared.
V squared.
Sorry. Y1 v squared over v plus
A
v squared over v squared plus b v squared over v equals to minus 1 over v squared multiplied by v squared dv dx. This cancel this. Do you agree with me? Now, one of these one will go. The 2 will go here. One of this one will go. At the end of the day, we have 2a y prime y1 v plus a plus b v equals to negative x. Any question? Do we all agree at this point?
Yes, sir.
Okay, let's continue. So when they give you Riccati question, so you can see what you are asked to solve before you pick the answer. But if you go to that all that day and you are doing the lotto, remember the question does not carry equal marks. You are just wasting your time. That is why we always have a lot of people that fail this course. Please, let's just be guided and do the needful first. So I can now I have the VDX here. A is a constant. I can take A out and bring my the VDX in. You add the VDX plus 2AY1V plus BV equals to minus A. Because when A moves to the other side, it becomes minus A. Then I can collate this one together by saying the VDX plus V is common here. I have 2AY1 plus B in brackets V equals to minus A. At this point, we have a linear function differential equation. So this case now, we need to solve this one. How do we solve this? Remember, I can write this one by saying dv dx plus p of x, you remember v equals to q of x. When you are using integrating factor, this is the way we solve integrating factor. Then I can now begin to solve this one by saying everything p of x now, everything here now is p of x. This a represents q of x. The v dx is there. Then it's possible for us to solve. If I want to solve this, it's going to be exponential integral of p of x. No matter what is p of x, the x, you multiply it, dv dx, plus p of x, exponential integral of p of x dx. I'm multiplying both sides, v equals to q of x, exponential integral of p of x dx. So at the end of the day, if I solve this one very well, I can mark these two together according to the law of integrating factor. That would be d of x, that is differentiation of x. We have v exponential integral of p of x dx equals to q of x exponential integral of p of x dx. So all I need is just to make v subject of formula after the integration. I would now say v is equals to integral, because until when you integrate both sides, that is when differential equation here will disappear. would that be integral of q of x exponential integral of p of x? Please write this area down. Divided by, remember you already make v subject of formula, it will remain integrating factor. Sorry. So it's going to be integral of p of x dx. Now, when we solve the example, you have the better idea of what I'm trying to do and how you yourself will also do it. So at times, some question might not require integrating factor, while some we ask you to do that. Okay, let's look at the example here. Example 2 here says solve y prime plus 2xy equals to 1 plus x squared plus y squared. Remember, for us to solve this problem, where your y, solution now, where y1 is equals to x is a solution.
But the way we stop before the example, you can cancel out the denominator and the numerator now.
Which of them?
The last one, v equals to integral of q of s, the integral of
Remember, integration sign is there, which you must integrate both sides. So how do you cancel it? You understand my point?
Yes, I understand your point.
So when you are solving it, be careful. Don't just don't just bring out your knife and be cutting anyhow. Don't worry, we will solve one example that will lead us there. I pray the time permits us. Let's be fast about this. Let's look at this. Okay. So remember, y prime means the y, the x. I can say equals to the y, the x equals to negative y squared plus x squared plus 1. But in this case now, what is our a of x? What is our b of x? Check your note. And what is our c of x? Before we solve it. Anybody? Check your notes. The one we just did. How do you relate a of x? A of x in this case is negative 1. Do you agree with me? Hello? Hello?
Yes, I agree with you, sir.
Okay, I think, let me see the question I gave you up. Oh, I'm solving question 2 already. Sorry.
What, because we have 2 sy there. So
I just discovered I'm solving question. So here we have y1 and this. Then here we have the y, the x is equals to. Look at the nature of the Riccati equation. Let's look at it. Look at the nature. The nature says the y, the x is equals to a of x, y squared, plus b of x, y, plus c of x. So you must first of all form this equation before you even start solving it. That is where I'm going. Now, I can go ahead now and solve this one by saying that I can rearrange this by saying y squared minus 2xy, take this one to the other side, plus x squared plus 1. I can call this one equation 1. Any question, please?
No, sir. It's question.
Now, what is a of x now? What is b of x?
Is one. The B of X will be
What is c of x? C of x is what?
It should be
Everything
one, so
remaining.
that's the question. Yes.
Everything that remains is c of x. Let's take note of that. So in this case now we said let y equals to, remember when we said let y equals to y1 blah blah, but in this case we have x and y. We said y1 equals to x. So let y equals to x plus 1 all over v. S plus 1 all over v. We can now differentiate the y, the x. If I differentiate the y, the x will be what? I have 1 minus 1 all over v squared dv dx, equation 2. Any question?
So how do you get this? Negative
Go and check your differentiation, young man. You just have to check your differentiation. Right? It's very simple. Okay, let me explain something because I will not explain it in the second question. So it simply means that you are asked to differentiate x now. If you differentiate x, what do you have?
We have 1.
You have 1. Okay, let me just use this one. You have 1. And this one is like v minus, sorry, you have 1. So which is the one we have here? We have 1 here. But it's the same thing as plus v raised to power minus 1. Differentiate this. It's simply, when you are differentiating this alone, you have what? Minus.
Okay. Yes, it's clear. It's clear. I understand, sir.
V raised to power minus 2.
Yes, I understand.
Dv dx. So it's the same thing as minus 1 all over v squared dv dx.
Yes, sir.
Do you agree with me now?
Yes, I understand now.
Any other question, everybody? Anyone? Can we continue?
Yes, sir.
Okay. So in this case now, we have it to be, we know equation 2. We can now equate equation 1 and equation 2 together. Remember, equation 1 carried the y, the x, equals to something. Equation 2 also carried the y, the x, equals to another thing. Then equate the two of them together. That is what I do. I did the other time. Equate equation 1 and 2. So once you write equate equation 1 and 2, it simply means that equation 1 says y squared minus 2xy plus x squared plus 1 equals to, equation 2 is what? 1 minus 1 over v squared dv dx. Making what? Equation 3. They now said substitute, we have to substitute y equals to s plus 1 all over v into 3. Anywhere you see y, substitute, because we want everything to be in x and v. So we don't want anything y. So we have it to be s plus 1 all over v all squared minus 2x into x plus 1 over v plus s squared plus 1 equals to 1 minus 1 over v squared dv dx. Any question? So when you open the bracket, the way we did the other time, we will have s squared plus 2x over v plus 1 all over v squared minus, when you open this bracket, minus 2x squared minus 2x over v plus x squared plus 1 equals to 1 minus 1 all over v squared dv dx. Any question? Silence means no question. You agree with me that s squared plus s squared will give us 2s squared. And we have minus 2s squared here. So the two of them will cancel. This will go, and this will follow. What else do we have? This will go, this will go. Any other thing, please?
No, sir.
Says who? Who said no?
Okay.
1 all over v square.
Thank you. One all over v square will also go. What else?
Sir, no, sir, that one cannot go.
It cannot go. Yes,
Yes,
because
okay,
he has a positive.
yes,
Because if he moves to the other side, it returns to positive.
Yes, sir.
You are right, Bernard. Thank you. But which one do you think he will go?
One can go one.
One can go.
Yes.
Yes. So you can see the way you will look at it very well. But you are left with 1 all over v squared equals to minus 1 all over v squared. Who can tell us what to do here? Mathematician in the house. I think I need to call some name. Eboza. Eosa, what do we do? Emmanuel, what do we do? Olorunfemi, Olufemi, PA, Nasri, what do we do? Emmanuel, what do we do? Yes. Egosa. Yes. What do you say? Yes,
we add 1 over 2 to both sides.
We add 1 over 2.
Squared. We add 1 over v squared to both sides.
1 over v squared. Okay, we had. I hope you guys are following.
Multiply.
Are you the one talking? Leave the mathematician alone. Okay, what else, sir? Any contrary opinion?
Yes, sir. So that we multiply. That goes by V square.
So you see, if you add it here, you are complicating the matter.
I'm telling you.
You will not get anything. So at this point, remember, when you have 1 all over x, let me just give you an example. How do I cancel x here? You cannot add 1 over x again. You can only multiply by 1. You can only multiply by x.
X.
So if you multiply by x multiplied by 1 will be x over x. That is where you can now nullify the x. You have 1. Do you get the trick?
Yes, sir.
Yes, sir.
So,
Yes, sir.
By V2.
Yes.
Multiply
Yes,
by
sir. Yes, sir.
V2.
Understood.
By V square.
Okay.
V square, sorry.
Yeah, you multiply both sides by v squared. So that's why you see me writing all this detail. Multiply both sides by v squared. If you multiply both sides by v squared, what do I have? I will have here v squared over v squared equals to minus v squared over v squared dv dx. Here we have 1 equals to negative dv dx. Are you following it? Now, in this case now, you don't need any, what do we call it now? Integrating factor. So all you need here is just to separable variable. Using separable variable, we have just cross multiply the s equals to minus dv. Then integrate the both sides. You have x equals to minus v plus c. Now that we know our our f is this, what is your, our v will not be, our v is equals to minus s plus c. Therefore, y is equals to x plus 1 all over. When you have 1 over v, just substitute it, minus s plus c, which implies y is equals to x plus minus s plus z raised to power minus 1. That's the end. That's the final solution for that problem. Any question? Does it make sense?
Sir, but the final answer, where do you begin? From where do you have y equals to s plus 1 over?
But you remember you said let
It's
y
from the
equals to
beginning.
s
Let
plus
y
1 over v.
equals to-
Okay.
Yes.
You have to, as a mathematician, you have to be following step by step, and you must remember each of the equation you are declaring, because you are still going back to that equation. Any question? Because of our time, can we go and solve this question? Probably next class we can check it. Solve this one, number 3. Solve y prime plus y squared equals to 1 all over x squared, where y prime is equals to x is a solution. So when you say y is equal to it's a solution, we can actually write it out by saying y prime plus y squared equals to 1 plus x squared. I can rewrite this one by saying y prime is equal to minus y squared plus 1 plus x squared. So at this point, like I said, the y, the x is equal to minus y squared plus s squared plus s squared plus 1. So what is our a of x? What is our b of x? And what is our c of x?
F is minus 1, B of S
Minus 1.
Then 1.
B of s is what?
B of S is.
Do you agree with me?
Yeah.
Yes, sir, 0.
Yes, sir, 0.
Remember, there's no y. It's supposed to
Yes,
be
sir.
y before you can say this is b of x.
Yes, sir.
Because our general equation says a of xy squared plus b of xy plus c of x.
Yes.
That is your general equation. So in this case now, you let your y equals to y1 plus 1 all over b. Which is the same thing, which implies is the same thing as y equals to x plus 1 all over v, the way we use it now. Guys, I want you to go and solve it. Differentiate the y, equate it together, then solve it, and let's see your y and your final answer. So, any question for me? Can I stop sharing now, please? Any question, please?
No question.
No question, sir.
Emmanuel, is it today your first time too?
No, sir, this is not my first time.
Okay.
Yeah, this is my third class. But last week we couldn't join because of the, I don't know, probably it's the network.
No, it was wrong. It was the link that caused the problem. And later I was able to, I think the only person that got it last week was Memuna, right?
Yes, sir.
She was the only one that got the link. I don't even know how she got it. And I think you are the only one that I taught last week.
No, 2 of us.
Who is the second person, please?
I don't remember the name, sir.
So I joined, but I joined.